Hello, good morning dear students. Today we are going to discuss a very interesting topic, inertia. It's interesting because you can relate all these examples in your daily life. That's why it is interesting. So you can grasp it more easily, and it's also a very important topic. We know that first law of Newton's first law of motion is also known as law of inertia. Now we can understand why Newton's first law is known as law of inertia. So before going to the section, let me define inertia. Let me tell the meaning of inertia. Inertia simply means inability. Inability means not able. This chalk, the inability of this chalk to move its position is called its inertia. What is that? This chalk can't move by itself, isn't it? It's called its inertia. So what is inertia? Inertia is the inability of a body to change its state of rest or uniform motion. If a body is moving along a straight line in a uniform motion, means with a 20 meter per second speed, it is moving throughout its way with 20 meter per second. The body alone can't change its speed. It's unable. It's not able to change its speed. That inability is called inertia. Or if a body is staying in the ground or somewhere else, it can't move its position by itself. This thing is called inability. Actually, this inability of the body or inertia is proportional to the mass of the body. Proportional means what? Proportional. Proportional means depending on the mass of the body. That means if there is a object, let us consider a big rock. What about the mass of that big rock? It will be very large. And let us consider a small box, small paper box, and it is empty also. What about the mass difference? The mass of the big rock will be much higher than the mass of the small empty paper box, isn't it? Which thing will be easier to move? Obviously, the paper box will be easier to move. If we exert a small force, or if we lift it and put it in another, we have to give a very small force only. To move a big rock, we have to bring a crane itself, isn't it? So, the inability or inertia will be more for this rock, and inertia will be very less for this paper box. Do you understand the topic? Let me give another example. See, I have a duster and a chalk. Two examples, a duster and a chalk. It's more easier for me to take this chalk than taking this duster because it's more heavy. So the inability or the inertia of this chalk will be lesser than the inertia of this duster. Or if I have I have a big rock or a big substance that is made with iron. So the inability of that particular object to move its position, to move from its position, this is called inertia. Now, inertia is directly proportional to the mass also. So, you understand the topic why inertia is directly proportional to the mass, or directly depending upon the mass. If the mass of an object increases, inability also will be increasing because it's more difficult to move a larger massed object than a small mass object. Examples as I given, if you are moving a small stone, it is easy, but moving a big rock, it's not at all easy. So the inability or inertia will be greater for the big one or the one with more mass. So that is the point, inertia proportional to mass. Now there are three types of inertia. They are what will be them? As we told in the case of Newton's first law of motion, inertia of rest, inertia of motion, and inertia of direction. always these three terms comes into play: inertia of rest, inertia of motion, inertia of direction. So the examples are from your common life itself. Inertia of rest is the inability of a body to move from its state of rest. Inertia of motion is the inability of a body to change its speed by itself. And third one, direction. Inability of a body to change its direction is called inertia of direction. Inertia of rest is the inability of a body to change its state of rest by itself. Inertia of motion is the inability of a body to change its speed by itself. Inertia of direction is inability of a body to change its direction by itself. So that is the three inertias: inertia of rest, inertia of motion, inertia of direction. Now let us go to the examples so you will understand more clearly. Consider we are sitting in a bus and the bus is in halt condition, that is it's stopped there. Let it be in one stand. A bus is staying in the Kirketala stand. So we are sitting in the seat of the bus. What happens as the bus suddenly starts? What happens? We'll be moving backwards, isn't it? The bus suddenly starts. We are sitting like this, and if the bus suddenly starts, we'll be moving backward like this. What is actually happening there, you know? We have an inability to move from our rest. Actually, at the first time we are at rest, we are sitting in the rest condition. The bus is also in the rest condition. But now, bus starts to move. But we like to sit at rest position. That is, there is an inability or inertia of rest in us. That's why we are staying in our position itself. But as the bus moves, what happens? Our head portion get backward. It's actually not getting backward. We are staying in our position itself, but the bus moves. So we are, see here, the bottom portion moves and the top portion, they tend to stay in our rest position itself. That is why when the bus moves, we are tended to go backwards. And another example is that maybe you have done this. If you have jamba fruit in your home, jambaka, you will be shaking it vigorously in order to get jamba fruit down. Or if you have some mango trees in your home, you will be shaking the branches vigorously in order to get mangoes fell down into the ground. So what is actually happening there is, mango is staying in the mango tree at rest, and at that point when the branches are moving, mango needs to, or it tends to be at rest itself. So what happens? Branches does only move and the mango is moving, is staying here itself. So when it moves 2 or 3 times, it gets detached from the stem and it fell down into the ground. Some more better example is the first one. When you are sitting in the bus, when the bus starts suddenly, we tend to move backwards. That is due to inertia of rest. So that is the very common example. Our next one, inertia of motion. Okay, one more example for inertia of rest. See, when you are taking some water in a glass, actually the water and glass is initially at rest, and when you are pouring it to the outer surface, water is at rest. But what happens, you know, we make a motion and then we take back the glass. So what happens? Water wants to stay in its position itself. That's why it stay here itself. When we bring this glass to here, water needs to stay here itself, but we take the glass. So water goes there, it continues its motion, but we take down the glass into the back side. So that is why water is getting poured out from the glass. That example also you can connect with this inertia of rest and motion. So again I am telling, first example is needed for you. Don't forget the first example. When we are staying or when we are sitting at rest in a bus, When the bus moves suddenly, we tend to go backwards due to inertia of rest. Now second one, inertia of motion. Imagine we are going in the same bus. So from Kedathala it started moving into Kaligavu region. So we are moving in the same bus. Suddenly when it reaches at Arimanal, one of the person get a hand for the bus. So bus suddenly stops there. The driver applies the brake. At that point, we want to go in a motion, but bus stops there. That's why we tend to go forward, and there is a chance to hit our head in the if there is iron rod or something, there is a chance to hit our head in the iron rod or in the next seat. So what happens here? Inertia of motion. We are continuing our motion. Inertia, our inability of our body to stop the motion by itself. That's why we are going forward itself, but the bus stops there. That is the example for inertia of motion. Hope you understood. What is that? When we are moving in a moving bus, when the driver suddenly applies the brake, we tend to move forward itself. Even now we want to move forward itself. That's why we are tending to go forward when even the bus stops. So that is the example for inertia of motion. And last example, inertia of direction. This example is also, we can take the case of bus itself. And now it reaches in the Inadi Valavu. You know that bend. So at that time what happens? The driver suddenly takes the bend. So if we are two persons are sitting in a seat, we will be giving a pushing effect to the other person. What happens? We want to follow the same direction, but the driver takes the opposite direction. He go by this direction. So we will be moving here. Or if driver takes this direction, we will be moving here. So what is actually happening there? We want to follow the same direction, but driver takes this direction. So we are tending to move in this direction, but bus is moving in this direction. That is why we are going outside when we are taking a right curve, and when we are taking a left curve also. When we are sitting in this portion of the bus, we are tending to move this side. So we are tending to move in the opposite direction of the bend. If it is in the right direction, we are tending to move towards the left, and if the curve is towards the right, we are tending to move towards the if the curve is towards the left, we are tending to move towards the right portion also. So to the opposite of the bend, we are tending to move our body. So that is actually, we wish to follow the same direction, but the driver takes a sudden bend over that region. So that is inertia of direction. That is inability of our body to move by itself, its direction, to change its direction by itself. That is the inertia of direction. Hope this topic is clear now. Inertia is the inability of a body to change its motion, its state of rest or uniform motion or direction by itself. It can't. If you are giving external effort, it can change, but by itself a body can't change its rest, motion, that is uniform motion or direction by itself. This inability is called inertia, and it is depending directly proportional to the mass. If the mass increases, inertia also increases. Examples are a big rock and a very small paper box. When we consider this, it's more easy to move a paper box than a big rock. Hope this topic is clear for you. Thank you for watching. Have a nice day too. You can ask any doubt in this section, as it is very, very important. If you have any doubt in this section, so you can ask. I'm repeating it again and again only for clearing this topic.